take it back out.
Hi guys,
So we're
welcome
gonna
back
talk
to the
about
vlogs.
some chords and arcs. Okay, and it's, I think those are both on there, or at least arc is on there, I know for sure.
Yeah,
Okay. We're gonna, once again, we're gonna talk about lots of vocabulary and then we'll have some examples, okay? So we'll do the vocab first and then we'll get to the examples. Okay. Okay, here's the deal. Some postulates first and then I'm gonna give you some terms. The arc addition postulate, okay? We have segment addition and angle addition postulate. What does it mean when I have those two postulates? What are you doing? You're adding what? Like, but not just any type of angles, they have to be what? No. Can I add, okay, when I have segment, or let's say I have angle addition, can I add this angle and this angle together for angle addition? No, what do they have to, they have to be like, they have to be,
They have to share a common vertex.
yeah, they have to share a common vertex, right? Yeah. Vertex. So same type of thing happens when you have arcs, okay? On a circle is a complete 360 arc, technically, okay? So I can divide a circle into segments that create little tiny arcs, okay? If I do that, this arc AB, okay, is arc AD plus arc DB, okay? So arc AD plus DB gives me the whole arc of AB, okay? Now, when you are dealing with arcs, there are things called minor arcs and major arcs, okay? This arc right here, AD, okay, this is a minor arc. And when you write minor arcs, you only need 2 letters. Okay, so a minor arc only has 2 letters with it, and it is a smaller portion. Okay? So a minor arc is a smaller portion. If I wanted to name a major arc, it's going to have 3 letters. So in this case, my major arc on this picture is A to B. Okay? Arc A, D, B. You have to name everything that's within that arc so that I know what I'm reading. Okay? Because on some pictures, let's say I have a circle, I could have a point here that's A, and I could have a point here that is B, and I could have a point here that's Z. This is my major arc, AZB, okay? It's the major part of the circle. But my minor arc is right here at AB. So that's why I have to name it so I know how I'm reading it, okay? If I say arc AB, that means my arc starts here and goes to this way, okay? If I say arc AZB, that tells me my arc starts here and I'm going that way, okay? It's important in a circle because that means I'm either going clockwise or counterclockwise, which means I either have positive degree or negative degrees, okay? Okay. So when you have circles and you have segments of them broken up, you have an arc plus an arc equals the total arc, okay? Congruent minor arcs theorem. Congruent minor arcs theorem. So now that we know a minor arc is just a small segment, okay, we can say this. In the same or congruent circles, so in 2 circles that are the same or in 2 congruent circles, which are all circles congruent? No, but are all circles similar?
Yes.
Yes. Okay. So in the same or in congruent circles, 2 minor arcs are congruent if and only if their chords are congruent. What's a chord again? Okay, so I have 2 different chords here. I have chord DE right here, yes? And I have chord AB. And these little tick marks tell me that they are what? Congruent. So they're telling me if those 2 chords are congruent and they're in the same circle, or they're in 2 circles that are congruent to each other, then that means that arc AB right here, this arc that it bisects, you see how it creates an arc right there? And arc DE that it bisects right there are congruent. So I know those pieces of that like little puzzle are equal. Therefore, if one is 12x plus 2 and the other is 6x, what do I do to solve? You set them equal to each other and you solve for x and plug it back in and it will equal the same thing. Okay? So If I have two chords in the same circle or in two circles that are congruent to each other, and those two chords are congruent, then the arcs that they bisect are congruent. Okay? The arcs that they create become congruent. Okay. Perpendicular chords theorem. Perpendicular means I create a, what angle? Right angle. If a chord, okay, chord, two endpoints on the circumference. If a chord is a perpendicular bisector of another chord, then the first chord is a diameter. So if two chords intersect and create a perpendicular bisector, that means the first chord has to be my diameter. Okay? Which means I can solve stuff because if I know the diameter, I can do things. Okay? So this chord EF bisects AB at a perpendicular angle. That means AB is my diameter. I know that's going to sound stupid because I know you can tell that's your diameter, but remember on proofs, I have to prove that it's a diameter before I can do things. It's your favorite. And then the perpendicular chords theorem, converse. What's the converse of anything? The opposite, okay? If a diameter is perpendicular to another chord, then it bisects the chord. Okay? So if my diameter is perpendicular to another chord, it bisects it, which means that it creates two equal parts. And once again, I got stuff going on there. Okay? You can divide things up. I'll give you a second on that one. Okay, let's talk about what's next. Like I said, it's lots of vocab today. Congruent chords theorem. Okay? Two chords are congruent if and only if they are the same distance from the circle center. So, if chord DE and chord AX are congruent, that means that XC and CY are equal, or the same distance. Okay? So AB is congruent to DE only if CX and CY are equal. Okay? So if they tell me, if they mark these for me, then I can automatically know that these are congruent. Okay? Or vice versa. If they mark this and this as being congruent, then I know that those segments are congruent. Okay? So your chords are congruent in a circle if and only if the distance from the circle's center to that chord is the same. Okay. Ooh, okay. Let's see if we can do this, which I actually need to think about something. We're going to talk this out. Because I don't know that I've given you enough information for this yet, but let's see if I can. If we can figure something out. Okay. Now, let's talk about this. It shows us that angle ACB is 50 degrees, right? Okay. They want us to find what BD is, what that arc is. Okay. So we've got to be able to do a little bit of math here. What do you know that arc DA is? Use some common sense. What is arc DBA? It's what? No.
It's the major.
Not what is angle ACB. What is arc DBA? What is this arc right here? Okay, it's a major arc, but what's the measure of that major arc? Use some common sense. What? No, you said it. What did you say? 180. Why is it 180? Because it's half a circle. Because DA is my diameter. Okay, so it's 180. So I know that the measure of arc DBA equals 180 degrees, yes?
Yes.
Okay, so at least I have a couple little starting points here, okay? Now, the measure of angles ACB is 50 degrees, okay? Okay, so if I know that the measure of angle ACB is 50, Look at that angle. Do you think that angle is smaller than arc AB?
Yes.
Yes. You think it's smaller than arc AB?
No.
Oh no, what?
Dude,
What?
not you.
She's mad because I won't give her a straight answer.
Oh, shoot. You said, see how that one's 50?
Yeah,
So
the
the other one be
arc,
like-
the angle.
Yeah, see how the, isn't the other one 130 then?
Yes. Good job,
I don't
Bryson.
know, that's what we're trying to figure out, Bryson. If angle ACB is 50 degrees, does that mean that arc AB is 50 degrees?
Yes, it does. That's my answer, final.
You wanna say yes?
Yes, I do.
Okay.
Wait, why you wanna say that?
Because it's a one, okay, the angle in general is 180 like the whole angle.
Yes.
So then the whole arc would be 180 too.
So the whole arc is 180
Yeah.
because the whole angle is 180. Good, Kayla.
Thanks.
So this whole
Keep
angle
up,
here, okay, is called your central angle. Okay? Any angle that is on the inside of an arc is called my central angle. So I have several central angles happening there,
Yep.
okay? And I have a central angle from angle A to like angle D, and you told me that's 180, right? So that then told us that arc DBA is 180. Okay? So that told us that arc DBA is 180. So if my central angle of AD is 180, and my arc then is also 180, then that means my central angle here of 50 degrees, okay, this central angle matches with what arc?
AB.
AB.
Yay.
Yes?
Yes.
And then I can use the arc addition postulate
Yeah.
to solve.
Okay.
Because I can say the measure of arc AB, right, plus the measure of arc BD equals what? Well, I can't do substitution yet, but yes, equals the measure of arc DBA, right?
Yes.
And we know DBA is 180, and we know that AB is 50, so I have this, right? And then I do a little bit, after substitution, I do a little bit of subtraction
Yeah.
or simplifying,
130.
and you guys are correct. Boom.
Wait, why did you think you didn't give us enough information?
Because I didn't.
What?
There's a rule that says that the minor arc is the same as the central angle, but I didn't tell you that ahead of time.
But we.
But you figured it out. Yes.
Good job, Caleb.
So
Bryson!
you and Bryson worked together on it.
Yeah, I
Because
know.
Bryson said 130 and then you put the pieces together. Okay, so yes, so the rule says that I didn't give you that a minor arc equals the central angle. Okay, if a central angle is 50 degrees, the minor arc is 50 degrees. If the central angle is 120 degrees, the arc is 120 degrees. Okay, so whatever your central angle is, your arc that corresponds with that is the same. So if I know one or the other, I can solve for about anything. Okay? Good. This is that property of that chord written again. Okay, it's just in color this time, makes it a little prettier. Congruent minor arcs theorem again. We already talked about this. If AB is congruent to DE, that can only happen if AB is congruent to DE. If and only if AB equals DE, if and only if AB is congruent to DE. Here's the deal. When you are doing proofs and theorems and whatever, okay, when you state something is congruent, you have not stated that it's equal yet. So if we are looking for a measurement, I need an equal sign, right? If we're looking for something that is similar or congruent, I'm using a congruent sign or a similarity sign. Now, if something is congruent, I know that it's equal, but you have to state that. And that's what this is doing. It's saying, if AB is congruent to DE, then I know AB equals DE, okay? That's what these are doing also. Just, it's rewritten, the theorems. In a diameter, the bottom one, perpendicular chords converse theorem. If a diameter is perpendicular with another chord, then it bisects the chord and its arc. So what happens here is, if this is perpendicular to a chord, not only is it bisecting the chord now, it's also bisecting this arc. So this portion of my arc and this portion of my arc are congruent / equal, okay? So you have to be able to know that. So if it bisects a chord with a 90-degree angle, then that also means that it bisects the arc that the chord created, okay? And then up here, that's the like opposite of it. If a chord is perpendicular, if a chord is a perpendicular bisector of another chord, then the first chord's the diameter. They had to restate that because of what it's doing. Okay. Let's see here. This is very like crazy. So let's look at this. We're gonna do one more. I'm gonna make a circle and we're gonna do some stuff. Let's say you have this circle. Okay. We're gonna pretend it's perfect. And let's say I have this. We're gonna have a chord here. A B. We're gonna have a chord here. D, E. We have our center point, C. This is like this. We're gonna pretend everything's drawn beautifully. And we're gonna have this. Okay. This is this. And this is this. Okay. How can I figure out what CF is? How can you figure out what segment CF is? Oh, I didn't put G and F down here. When you make a point, you have to have another point. Okay. So how can I figure out what segment CF is?
Someone else was trying me and Bryson did the last one.
What type of lines are those? Perpendicular to the chord, yes?
Yeah.
From the what point? From the center. So if they're perpendicular to the chord from the center, what does that mean about those segments? That they're what? What? They're not the radius. A radius goes from the center to the edge of the circle. That's not going to the edge of the circle, it's going to the chord. But if it is the chord's perpendicular bisector, what does that mean? They have to be what? What? Congruent. So how can I solve for CF?
First, yeah.
So then we go to each other because I can go.
Yes.
I said, she heard me.
Sorry, I did hear you, I just didn't respond.
Yeah, Kayla.
Now what? Yes,
Come-
subtract 2x,
Combine, right, turn.
and you get 2x minus 11 equals 7, add 11, right? 2x equals 18, divide by 2, and x equals, which means I'm not done yet because I wanna know what CF is, so I take 4, multiply by 9, what's that? 36 minus 11 is 25, right? Okay, and then I can always double check because I can say 9 times 2 is 18 and 18 plus 7 is,
You just plug it in, basically. Right, it's basic math, yeah.
beautiful, okay? These are the things you're doing on your homework, Caleb.
Got it. Come on, Bryson.
Bye, friends.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?
How about Bryson?